Assalamu alaikum. This is me Eina Zia with my partner Ibad-ur-Rehman, and today our topic is Fibonacci heap.
Fibonacci heap is a collection of trees. These data structures serve dual purpose. It supports a set of operations which are known as mergeable heap. Secondly, several Fibonacci heap operations run in constant time, which make this data structure suitable for applications that involve these operations frequently. These are some properties of Fibonacci heap. It does not need to be a binomial tree. The siblings are bidirectionally linked with each other. Pointer always indicates the root which has minimum key. The degree of each root node does not need to be unique. Some nodes are marked.
This is how Fibonacci heaps are represented in a circular doubly linked list format. Let's start from the minimum. At the minimum pointer we have 3. If we look at the right side of 3, we can see that it is linked with 17, whereas it is linked with 7 to its left. Similarly, 7 has 3 at its right and 23 at its left. But if we look at 23, it has 7 at its right and 24 at its left. Likewise, 24 has 17 at its left, whereas it has 23 at its right, and they are linked like so. This is how each label will be linked to its siblings. But if a node has 0 degrees, like in the case of 23 and 41 and 35, they will be linked with themselves. The following operations are performed by the Fibonacci heaps, having the given time complexities. To create a Fibonacci heap, the minimum pointer is first indicating at nil. Since there is no element present at the very beginning, the heap is created, but we will insert the values one by one.
Now I will talk about one of the operations which is called insertion. First of all, we create a new singleton tree. Add the tree to the left of minimum pointer. Update the minimum pointer if new node new node value is smaller than current min key.
As the name implies, we extract the minimum value out of the heap. Let's find out how it's done. First, the minimum value is extracted, which causes its child nodes to join the root node as shown in the next step. And it can be seen that after the minimum value is extracted, the minimum pointer shifted to its right, which is 17. But we can see that 17 is not actually the minimum value, it is 7. The highest degree of this heap is 3. If we look at the previous step, the highest degree is 3. So we will consider an array of size 3. As it can be seen that many nodes have same degrees, so we will consolidate such nodes under some conditions. In this step, we can see that 17, which is the minimum pointer, has a degree of 1. So we will link it with the first location of array. Now moving towards its right, which is 24, and it has a degree of 2, which will be linked to the second location of the array. The next pointer will be on 23, since it is at the right of 24. Having a degree of 0, it will be linked with the 0 location. Moving further towards the right, we have 7. But the degree of 7 is also 0, and 0 location is already occupied. Here we will now consolidate. We will compare these two nodes and decide which one is lesser. Since 7 is less than 23, 7 will become the root and 23 will become its child node. The pointer is now at 7, and the degree is 1. But first location is already occupied. So we will again consolidate, and this process will continue till the entire array is filled, following all the properties of minimum heap. The final result will be something like this. Thank you so much for listening to our topic.